We will now determine the Laplace transform of this expression, that is t times of cos of kt. And for this, we will utilize this theorem as well as the formula to find the Laplace transform of cos of at. So according to this theorem, Laplace transform of t times of f of t is given by negative of d by ds of f of s. So it's basically the negative derivative of the Laplace transform of the function f of t. So we will also utilize this Laplace transform formula, which says that the Laplace transform of cos of at is given by s over s squared plus a squared. So when we apply the theorem as well as the formula to find the Laplace transform of this expression, we write down this as negative d by ds of the Laplace transform of the cos of at. So for that, we can use this formula, that is the Laplace transform of cos of at is s by s squared plus a squared. So in place of a, we have a k over here. So when we apply the formula, we will have s divided by s squared plus k squared. Now we have to find the derivative of this quotient and multiply by -1. So for that, I'm going to use the quotient rule of derivatives. So in that, we have to first write down the quantity square of the denominator expression. And now we write down the denominator expression multiply with the uh, this expression, that is s, the numerator expression, derivative of this numerator expression. Derivative of s is 1, then we put the negative. Now we take this numerator expression, which is s, multiply with the derivative of the denominator expression, that is we have to find the derivative of s squared plus a squared k squared. Derivative of s squared plus k squared, when you apply the power rule, derivative of s squared is 2s, and k is a constant, so it becomes 0. So we get this expression. I have to put the negative over here. So let's simplify this. We have negative of s squared plus k squared in the numerator. Negative s times of 2s is negative 2s squared. So this is what we have in the numerator, divided by the denominator expression, which is s squared plus k squared quantity squared. What is that? S squared minus 2s squared is negative s squared. So in the numerator, we have k squared minus of s squared, and we multiply this expression with the negative. It's basically a -1. So therefore, we have to flip the signs of the terms inside the brackets. So therefore, this becomes s squared minus of k squared. So in the next step, we can write down this in simple form as s squared minus of k squared over s squared plus k squared quantity squared. So this is the Laplace transform of the expression t times of cos of kt.